This is Duke University.
So first, I want to maybe, this won't be news to you, but I want to debunk a bit of the myth that we're dealing with some sort of new phenomenon of information overload. So let's just look at a few quotes. So just bear with me, maybe. So in 2010, with the amount of information online, it's very easy for people to drown in useless information that they do not need in their business or in their lives. If you try to absorb all of the information you can find online, then you'll experience social media overload. Of course, we can go back quite a bit further, and we go all the way to Marshall McLuhan. One of the effects of living with electric information is that we live habitually in a state of information overload. There's always more than you can cope with. 1684, going even further back, we have reason to fear that the multitude of books which grows every day in a prodigious fashion will make the following centuries fall into a state as barbarous as the centuries that followed the fall of the Roman Empire. So really, this is horrible stuff. What are we going to do with all these books? So what I would say is don't panic. This is not a new problem. And it's actually, the search for solutions is also not new. So utility of lexica comes not from reading it from beginning to end, which would be more tedious than useful, but from consulting it from time to time. Now, of course, take this with a grain of salt, Conrad Gesner. I'm not suggesting that we don't need to read books from beginning to end. I guess I'm suggesting that we can create tools that can assist us in the process of analysis or search, which can complement reading. So what I would argue then is the real problem is not and never has been the wealth of information. The problem is the lack of appropriate tools for filtering, exploration, annotation, and collaboration. So the pace of the information dissemination exceeds the pace of tool and technique development, and we're always catching up, and that's just me. So, so where would we go with this? Well, there's a long history as well of visual languages. So creating visual representations of meaning from cave paintings in Lascaux, and we have Egyptian hieroglyphics, etc. But also more recent things, Larkin's Mountain Peaks of Prophecy, a series of wonderful sketches of biblical stories which sort of try to literally represent the information with an illustration. So that's myth number one I sort of want to try and debunk, that information overload is some new problem. We don't know what to do with all this text. The other one is about big data. So this is the images if you search big data on Google. You can see these silly images with lots of ones and zeros and things. Really, big data is a real thing, but it's also surrounded with a lot of hype. And a lot of people might think of big data and they might think of things like this, right? So weather system modeling, computational astrophysics, medical imaging. And what I think, for me, in my research career in the future, this is also big data, right? So dealing with all of the words in all of the books, or all of the words in all of the tweets from everybody over time. I'll just give you some examples from different areas of where we might want to work with language data. So the first one is looking at tools for communicating in real time. So we have computational interventions for communication, like translation algorithms. So I might write something and have it translated to give to somebody who speaks another language. Normally what you get is a single best sentence, the hypothesis for translation. And in this project, we looked a little bit at teasing apart the underlying algorithms to get at other alternative translations. Looking at content analysis from various different purposes, so a single book, a large collection of legal documents, and even for applications in computer security. And finally, if we have time, looking at a couple of examples from computer science researchers, or not computer science, linguistic researchers who are interested in understanding things like discourse analysis. So we're taking from WordNet the hyponymy relationship, which is going to tell us things like game is an activity, chair is a type of furniture, and this continues on. So chair is a type of furniture, which is a type of a household object, which goes onward. And we're also doing some simple techniques like stemming the words so that different versions of the same word are going to be counted the same way. Taking these two pieces of information, part of speech tagging, putting it all together, and we get a diagram that looks like this on the right, but it's interactive. And the idea is that the structure of the diagram is using this is-a relationship, and the color of the nodes, the color of the green wedges, is the amount of times that term or its synonyms occurred in the text. So let's look at a better example. So here, this is a general science textbook. And we're looking at, it doesn't have, for example, the word beetle does not occur at all in this book, but insect does. So if I click the word animal, one of the things that I like to do in my work is make sure that we can get back to the original text. So these are all the paragraphs in the book that contain the word animal. And we can go directly to the location of the word animal. So what this means is that placental mammals, there's more data out here. It's just been truncated because of the view, but we have this tree goes on. And the more outward you go, the more specific you get. So fish is an aquatic vertebrate, is a vertebrate, is a chordate, is an animal, as you go inward. So if you want to try this out, actually, I've got some students who've re-implemented this as an online tool. If you're interested in coding for the web, I would recommend taking a look at D3, which is a coding toolkit for visualization online. And this has been re-implemented in D3. You can actually go there and upload your own documents and use it. It's also got now named entity extraction, so you can correlate the general purpose nouns that are coming, or the general abstract nouns that are coming from WordNet with the actual named entities in your text. But I want to introduce you to some ongoing research we're doing in the area of password analysis. And I think this is interesting. For me, it's interesting from a sort of social interest point of view, because I feel like I'm getting into like the secret things that people think when they're writing their passwords. But for my colleague who I'm working with, she's a security, and she's interested in better password policies. So can we improve the way that people write passwords to make them more secure? So our first project in this area was looking at the number patterns in passwords. So we have a collection of millions and millions of released passwords, real passwords that people wrote. And we're looking at, our hypothesis was that the numbers that are in the passwords are not going to be randomly distributed, right? That probably they're going to be dates. So we're looking specifically at whether or not these numbers match a profile of dates, and if they do, what dates do they match? So what do people already know about passwords? Well, we know that people use keyboard patterns, so they type ASDF as their password. They use the word password. Number one password is the word password. Maybe password 123. And some other common words. Actually, it's interesting. Princess is a hugely popular word, which is something that I'd like to talk to people about later. The word prince doesn't actually very much at all. And we know things about keyboard patterns and things like that. So what we're interested in here are semantic patterns. So what types of dates are being used particularly in this project, and what kinds of words are associated with the dates. And if we find that there are patterns, then we can do things like ban certain passwords, like Christmas Day, or we can provide guidelines that might improve the creation of future passwords. So from the security point of view, what the impact of this is that if we use all of the possible dates, we have 15.4% of the possible numbers represented, and we can crack 27.5% of the passwords. If we reduce this to dates based on our patterns that we found, so things like holidays and other things, we only need to use 7.26% of the available dates, and we can still crack 22.39% of the passwords. So we're making the cracking faster, basically, because our dictionary is smaller. So this is bad. But it's interesting, because if we don't do it, somebody else might do it, and we would like the world to know about this vulnerability. If we scale up even more and start looking at an entire collection of long documents, I want to tell you a little bit about a project I did in collaboration with IBM Research around analyzing the entire history of the US circuit court system. What we worked with were the decisions from the US federal court reporters, the circuit courts. And what we have is well-formed data with good metadata headers, generally speaking, that have been organized by some outside companies, but also an independent organization called bulkresource.org. And we were able to download that data and break it up, put it in a database, and we basically have now documents. These are the decisions from all of the different circuit courts, as well as from the different roughly geographical regions, as well as the DC circuit and federal circuit. And we also know when the court document was written. So why are we doing this? Well, the question from our colleagues at the Berkman Institute at Harvard was whether or not people were doing what they call forum shopping. So are people bringing, or companies specifically, bringing their case to a particular court district because they have offices everywhere where they think it's favorable to make a decision about their case. In terms of the analysis infrastructure, what we had to build was an ability to take this XML data, break it up, clean it up, apply some simpler natural language processing techniques like the ability to stem the words. What's interesting here is we actually use a technique called reversible stemming. So we're chopping off ends of words, and stemming actually can do things like you have the word lovely and it becomes love. But lovely is actually interesting to somebody who's actually doing the analysis. They don't, like, love is deficient because we've lost information. So we're actually, in the view you see at the end, putting the stems back on, or at least the most common stem for that group. Removing common stop words, again, that's something that you can turn on or off because even the stop words, in terms of their distribution across the court districts, may be interesting. And also, instead of just a static list of stop words, which is often used, we actually created an algorithm for dynamically detecting stop words. These are words that are common uniformly across all districts, and therefore not so informative for this question. And also they swamp the view because they happen so often, like judge and court. We also removed what we call hapax legomena, words that just occur once. They're highly distinguishing for a particular court, but they don't occur often enough to actually be reliable as a signal. We use an alphabetic ordering to allow people to search for words that they expect might be there. And also to balance the spacing. Otherwise it just looks like it's really difficult to look at triangular columns. And then we created these edges, which we'll talk about in a second. So just as a sort of sanity test we call it in computer science, to make sure our algorithm is working, for example, the first run of it, we get this. And this clearly shows that something is happening correctly because we have the names of the judges and the names of the locations in the Second Circuit. So these would be expected to be highly distinguishing for that court district. So the next thing we did was remove all of the proper nouns. So after that, we start getting something like this. This is before the reverse stemming was added in. So you see these are the stems, which are not very readable. But now we start seeing something that is more interesting because we have the contentful words that are in the Second Circuit. So for words that occur across court districts, we created this system of connecting them with edges which are sort of hinted at in the visualization and then become apparent if you hover on that location. So we call them edge stubs. We have problems with the nuances of these kind of linguistic resources that are available. So for example, in WordNet, at the same level of specificity, we have animal foot, finger, leg, but also the fissure of Sylvius, which I would say is quite a bit more specific term for me, not being an expert, than leg. This is a particular fold in the brain. So there's some issues with the underlying resources that need to be worked out how to deal with them. Dealing with proper nouns, transliterating proper nouns from one language to another automatically, including them with sentiment is a really important thing. I mean, from the business community, especially business informatics and doing things like business intelligence, knowing if people are saying bad things about my product or my hotel. So with that, I'll just stop and thank my collaborators here on the bottom left and my students on the upper right, and some funding agencies. And we're sort of out of time, but I'd be happy to take your questions or stick around and talk to you after. Thanks.
Produced by Duke University. Online at duke.edu.